So let's introduce today's speaker, Nick Chong. Again, entrepreneur and also the engineer. So he's head of product marketing at Zoom. Before that, he worked for Cisco and some other company. And he also have a business degree and an engineering degree, computer science. So let's welcome Nick to give us a talk.
So I'm going to do this whole thing in Chinese, you know that. So if you take your business card out and it has the word driver in it, and it's a description, you may want to look for a new job after the discussion today. Okay. So the fact is communications, like anything else, has its trend. And the fact is, we all, in many degrees. So the fact that there are a lot of transitions going on around communications. Much as you've heard, all the transitions going around cars and the elimination of drivers, there are some trends right now going on around the transition of communications as a whole, right? So what I'm going to talk about today is more around some of the transitions and the trends, as well as the challenges for engineers as a whole as you embrace the transition. There are lots of factors that will affect how you engineer, how you design, and how you would master in the new field of communications in the software-defined environment. Okay? So first of all, in communication, this is not new, right? All of us communicate in one form or the other. The most traditional way of doing it is via telephone, right? Or in the past, there used to be radio communications. As you know, if I have two young boys, when I say radio, they ask me, what is that? I mean, that is clearly a sign that companies like Radio Shack is going to go out of business. Right? So with that in mind, communication is still there. It's a different form of communications at this point in time. Okay? Same thing with computers. It used to be desktops and laptops and mainframes, and you guys may be in the age of mainframes and dumb terminals, and right. I mean, if you look forward from now, hopefully the word Windows may ring a bell in a few years. It may not. Who knows, right? But the fact that there is a transition even in laptops and desktop as well. Last but not least, and the last two things that are out there is, you guys have been in companies where you walk in and you go to conference rooms where you have meetings, you sit in there and you talk to someone else, right? You have to actually physically have to be in a room to talk to someone else. You guys are thinking, well, what is that, right? You have to be in a room to talk to someone else. Those days are gone, right? You can talk to someone else on any place at any time nowadays. You don't have to be physically anywhere. Think about this event right now. You guys are sitting here. Do you think a few years from now you'll be sitting in this room to have an event? Mm-hmm. Right? Good.
For the senior people, just to get together.
Right? Exactly. Yeah. For the seniors, right? I agree with you. Okay. Same thing with the concept of tablets and mobiles, right? I mean, obviously, you guys. I can see all of you guys have mobiles running around. Even my kid, the only word that he knows is iPad, right? I mean, so there's transition around communications as a whole. So the fact is that we still need to communicate, whether it's face-to-face or whether it's by phone or whether it's emails or whether it's collaborative, right, document sharing. There's still lots of communications going on, right? But the fact is that the transition is moving. It's completely moving from what we used to do to the new ways of doing things in communications, okay? So if you look at the beginning, for those that are old enough, which is not many of us here, there used to be a thing called telephone conferencing, right? The days when it came, we sit down and says, oh my God, we can actually have 5 people calling in and have a telephone conference. That was like amazing, right? That was like great. People were starting buying services, buying PBXs, for conference and variety of all those things on there, the physical hardware to do audio conferencing. Then, you remember those days where you watch, I think, what's the movie, the cartoon now? They have this video conferencing. People are talking on video, and people are like, oh my God, it's video. And then companies popped up with video conferencing. You go in a room, you have a video conferencing, you can talk to multiple sites. They're not that great quality, but you can at least communicate. So video conferencing came along, right? Then companies then says, okay, those things are great, but in the world of web browsers, in the world of digital technologies, how do I communicate now? Now that I've got laptops, I have got PCs, not just phones or conference rooms anymore. How do I communicate? Then came web conferencing, which is essentially you can screen share your content. WebEx, GoToMeeting, where you can screen share content to communicate as well, right? So the transition went from being telephone to room-based to web-based when you have laptops and PCs, right? But the newer transition right now is moving everything away from those, which you still need, to the cloud, right? If there's no mention of cloud, no one's going to be here. So the fact is that the cloud is where we're transitioning to. So with cloud, essentially everything that you've done in the past is just done in the cloud, okay? Why do you want to do that? What are the benefits and what are the challenges of doing it in the cloud, okay? So that's some of the things we'll talk about here, right? So essentially, what is cloud communications? Cloud communications or collaborations is essentially just a new way to build, to deploy, and to scale your business communication system, right? Something you've done in the past, but it's just a better way to deploy it and to scale it and at a more affordable and more effective way for your employees and users. That's the key here, is how do you deploy it? Okay. Some benefits. The benefits of cloud-based communications are largely on the left side here. First of all, they are software defined, right? In the past, remember, telephones first come out, it was all about the telephone. What does it look like? How many dials you have? How many buttons you push? It's all about the physical hardware, right? But nowadays in communication, it's all around the software. How the software communication goes on. Okay? It is low-touch deployment. You don't really even have to be in a place to deploy communications anymore. You just have to download a piece of software, and then there you go. You can communicate, right? Think about in China, where the communications right now is based on Snapchat, WeChat, and Line. That's how people communicate, right? It's not about whether they have a physical phone anymore. They can use it on any sort of things that they buy. It can be a sort of smartphone, or it can be any sort of smart devices that they can use. But it's again low-cost deployment that goes to millions, right? Massive scalability is another key thing, right? With cloud-based technologies, right? Things about all the communications today that you have out there. They are huge. They're massive. They can be easily done with millions and millions of people. And we'll talk about considerations here when we do that, but essentially they can be massive. Okay? Dramatic cost reduction. Ultimately, regardless of what you do, you've got to be able to hit the pocket. You've got to be able to tell someone that, hey, you used to spend millions of dollars in this equipment. Now, you only need to spend a fraction of that to do that. So that means that it's interesting and they will invest in it, right? So it's got to be a dramatic cost reduction in terms of benefits. And last but not least, the concept of ecosystem friendly is actually quite important in the software-defined world, in the cloud world, whereby applications can build on top of it, right? Think about right now an iPhone or an Android phone, right? What makes it take is the fact that the applications running on it. There are lots of applications that can run on it. Look at the smart car that he talks about. It's not a car anymore. It's actually a platform for applications to run on top of it, right? So it has got to be ecosystem friendly when it comes to cloud, right? So those are the benefits of doing cloud-based communications. But there are distinct challenges in doing it correctly and doing it right. What are the challenges? The first challenge in building cloud communications, whether it's asynchronous or real-time, is your architecture. The architectural design will change because of the way you migrate the intelligence of the platform, right? In the past, intelligence lies on that device. Today with cloud, the intelligence lies on the cloud, distributed, as well as on partially device and on applications. So there's some architectural considerations, and I will go into details of how we design around that for a cloud-based architectural constraints. Okay. And then there are the concept of hardware. Now, even though cloud-based communications are still based on cloud and software, there are some dependencies on the hardware itself, right? Be it a mobile device, be it a laptop, be it some sort of device in a car, whatever it is, there's some sort of considerations on that in terms of hardware, right? And the good news is that the hardware is evolving, right? The bad news is that there are still limitations on hardware in terms of power, processor, and speed. Okay? The third thing with challenges with the cloud is because of the massive scalability, you got to be able to do it in cross-platform. How many, for example, in Android, how many variations of Androids are there? A lot. A shitload of platforms out there on Android that are not consistent. Even on iOS, there are lots of platforms on it, but at least iOS controls most of it, right? But now you've got iWatch, you've got iPad, you've got iPhones, your iTV is coming, you've got Apple TV, you've got so many platforms inside it, right? So you've got to be able to deliver that in a true cross-platform, and that's not easy, okay? Last but not least, when you do it in the cloud, you've got to be able to provide the same level of user experience and quality, right? The reason why companies like Snapchat, in terms of communications, of WhatsApp, and those communications products work well, it's because they're reliable. You deliver a message, you get it. You send a picture, you get it. It's reliable. Can you imagine if you have that platform, you send a picture and nobody gets it? Nobody's going to use it, right? So you got to be able to have a high quality and a great user experience, and it's simple as well to be able to make it effective when it comes to cloud. Okay. And last but not least, the go-to-market strategy for cloud is completely different. It's not the way it used to be anyway. In the way we used to sell communications, someone goes out and sell it to you, someone proposition to you, you install it, you test it. Now in the cloud, the go-to-market is all around freeware. You have to get it for free. How many people actually buy apps here initially? Very little. You try it for free, even for business app, and if you like it, then you buy it. Okay? The go-to-market is becoming a freemium model. Okay? So the go-to-market is also changing. So challenges, benefits are great, but there are some distinct challenges on how you actually market and position a cloud-based business communications and collaborations tool. So ultimately, when you say software-defined communications, what essentially you're doing, you're unifying communications that runs on three things in terms of business. Audio, you still have to talk. Video, face-to-face, and then collaboration, sharing content, annotating, recording, right, of collaboration features, where do the contents go, all those things on there. You've got to be able to unify these communications and then be able to access it from any device, from tablets, telephone, to room systems, to any sort of device in there. If you can do it right, you have unified communications, and you've now also put it on the cloud. So let's talk about the trends in terms of engineering to be able to design and solve these problems when it comes to cloud-based communications. Okay, we'll talk around the four areas that I think are key. Well, when you guys out there right now going out to sort of understand or deploy the next generation communications platform, you see that these are the four key areas that are quite critical. Okay, one is obviously the cloud. How do you scale? How do you design a massively scalable cloud? Okay. Second is around mobile. The fact is that you cannot design a product nowadays without the concept of mobile. The young boy out there, the first thing he's going to do is on mobile. Okay? He's never going to touch a laptop in his life in the future. He's going to be on his mobile. Okay? It may be a variation of that, but it's going to be mobile. So mobile first design is really, really key when it comes to engineering. Okay? Hardware will continue to change and evolve, right? So how do you then leverage off-the-shelf hardware as much as you can? In the past, we used to design really expensive, what do you call that before FPGA comes? What was that? ASIC. Remember, you guys remember ASIC days? And then there's FPGA and so on, right? The fact is that it is transitioning, right? You can't rely on just, custom-made hardware because that is costly, time to market, cloud-based does not work, okay? So you got to be able to sort of leverage off-the-shelf hardware components to go to market, okay? And last but not least, we'll talk about APIs in terms of how, when you build your product, it cannot be standalone. You've got to be able to have integrations, APIs, SDKs to bring apps on, okay? That's how you're going to have to do when you bring a cloud-based environment when you design that. So to design a scalable architecture for us requires two things. First of all, there are lots of devices that come on to communicate, right? Anywhere from a Mac, a PC, to a telephone, to a traditional room system, 323 SIP room system protocols coming in, to new software-based room systems, to telephones calling in, to anything calling in to communicate in our cloud, right? So it's not it's not just one thing anymore. It's really a variety of things, and you're not talking about one device. You're talking about millions of devices. When we started the company 3 years ago, we launched our product roughly 2 years ago, back in February of 2013. We have just announced right now we've got 40 million participants that have used our service in less than 2 years. This is the business applications, right? 40 million participants have used that, right? We have over right now 65,000 businesses that run on it, right? So it's really quick in terms of how this scales, right? Even companies like Snapchat and WhatsApp, those are even nuts, right? Those goes proportionally crazy, right? So in business applications, to get into that model, you've got to be able to develop a highly scalable infrastructure in the back end. So we do it in both ways. So first of all, in the back end, the cloud, we built it based on leveraging something that's existing today. It's a company called Amazon, right? For any startup today, when you're trying to come out to build a software infrastructure, you can either do everything on your own, or you can leverage an infrastructure out there that's been developed, and that's Amazon Web Services. Okay? Amazon allows you to very quickly turn on your infrastructure, turn on your web, your backend, scale it out relatively quick. So what we've done is essentially we've developed two components in there, and the left side is actually done sort of the front-end technology for web browser and client to come into our infrastructure. In the back end here, we have different sort of servers that perform different functions. The top is the web server. That's where we sort of have the web interface and the web front end to communicate. Then we have the XMPP server, which is for group messaging, for group chat using XMPP. Then we have the meeting servers out there where meetings are being held. There are two components in there. One is called the zone controllers. We control the zone. And one is the multimedia routers where traffics are being traversed to switch. Okay? Then we have our CC backend, which is our cloud room connector back there as well. So essentially, we built this infrastructure on Amazon, and then we replicate them very quickly across Amazon's instances. So we can scale it across the different parts of Amazon and scale it out really quickly by building it on top of Amazon. Okay? And then you obviously have to build a layer of security around it, obviously. And then you've got to be able to optimize it using your CDN so you can get traffic out in a more optimized way as well, right? But the fact that if you can build and architect it on top of Amazon, there is a quick benefit. Now, we were the first company to develop a real-time platform on top of Amazon. Now, you have seen YouTube not YouTube, YouTube's on Google, sorry. You have seen Spotify on Amazon, Netflix on Amazon, but those are asynchronous. Is one way, they're delivering content to you. Whereas with communications, it's real time, it's two-way communications. So we were the first to develop that on top of Amazon to do real-time communications by building on an architecture that we know how to scale it out. Okay? The second thing that's once you have the architecture done right, you've got to be able to scale it out using zones. So we have multiple zones in the east and in the west of Amazon, and we also have one in China and in Europe as well to do that. So you develop zones inside it, and the zone has load balancing architecture as well as redundancy across that as well for the disaster recovery as well. Okay, so this is all architected using software, using instances, and using Amazon globally across the world. Okay. We have around almost 95 people now. Out of them, there are around 65 of them are all engineers, and roughly 55, actually with more now, we've got around 55 of those engineers actually based in China as well. So we spend a lot of time making sure that the technology not only works in the US. US is a big market, but it must work in China. China is going to be a dominant factor regardless of what you do, especially when it comes to communication, to be able to get it right in China. Okay? So we're the first to be able to allow good communications between US and China, real-time communications on that as well. Okay. So we scale it well, grow it well in our data centers, and then we sort of design around that. Now, as we continue to grow, we've also started building out some infrastructure on our own as well. While we like Amazon, we cannot rely on Amazon all the time. There are two reasons why you can't rely on Amazon all the time. If Amazon has a problem, there's no good way to know what exactly is the problem, right? That is one of the challenges. So we have built out some infrastructure on our end. For some of our customers, we actually use our own infrastructure. We still leverage Amazon for the back-end services, but we have some infrastructure on our end to be able to sort of manage and control that a little bit better, right? Second, as you grow, Amazon is not going to be cheap. Okay, Amazon is cheap in the beginning as you're growing it out, but in the long term, it's not as cheap as you think. Okay, so you got to figure out, the balance within the cost point, right? So, at different stages of your business, you have to figure out when it makes sense to sort of have a hybrid versus a standalone Amazon, and in the long term, do you build it out on your own in the long term? Okay. The second piece is around mobile design. It's really key as you're building technologies in the future to be able to do mobile-first design. For example, for us, we have some requirements that we have to do, and then we have to figure out how to do a mobile-first design. Okay? We want people to be able to start meetings and start a real-time interaction directly from your phone. You don't have to, you don't have to use a computer. You don't have to use anything. You can start the meeting on your phone. You can control the meeting from your phone. Traditionally, most of the solutions out there, you have to use a PC or a Mac or something else to control the meetings. We don't want to do that. We want to be able to do mobile first. When you're in a meeting, you can control the meeting. You can look at everyone in the meeting. We can support up to 200 videos at a time. That means on a mobile, you can slide, you can go up and down, you can mute, unmute someone, you can kick someone else. The experience is on the mobile, okay? And that's key. You got to be able to screen share. I mean, most of the time we use a desktop to screen share, but most people now are on mobile, right? They're talking, they're driving in a car, they've got content that they want to share. How do they do that? So we came up with a concept of mobile screen sharing. So you can be using your mobile and screen share the content in your mobile, okay? And that is key, right? Because you have games. You guys have developed some games. You want to show off to your customers, your prospects. How do you do that? You can't do that traditionally. Now you can use your mobile and screen share the content on your mobile, okay? And then obviously I've got other things like annotation, collaboration features and group messaging, kind of like a WhatsApp sort of messaging. You have to build those in as well. So those are the requirements to do in mobile first, to do it in mobile. But then how do you do that? So if you're thinking of building a product and it has to be mobile first, then you still have the considerations of how do I do that. First of all, quality is key. You've got to be able to bring the same level of quality across platform on mobile. If the quality is not good, it's not going to be good, especially when it comes to video communications or audio communications. Can you imagine if you're seeing someone, that's supposed to be pretty and she's not on the phone? I don't think she wants to be on the video call with you, okay? So you got to make sure that the quality is there and it's cross-platform. That's not so easy, okay? So first of all, there is always the concept of standards and protocols, right? When you guys design things, there's always the concept: do I use open source codecs? Do I use open source protocols? Do I develop my own, or do I wait? So there are protocols out there, for example, for video or audio, which is based on H.264 or H.265, and those are protocols. And then there are protocols out there that are based on concept of VPA, the VP9 for that as well. That's more Google-based stuff. And then now there's all this web RTC protocols that are running around as well, being discussed on all those things. So there's web-based communications as well. So ultimately, you have to decide. The problem is most of these protocols were built years ago, and when they built those protocols, it was not designed for mobile. That is probably the biggest challenge. So when you're trying to design a product for mobile, you're looking back at old technologies and old protocols, and you're trying to adapt it to mobile, and that is hard, okay? So you're gonna have to figure out how to do that. We ultimately had to sort of design our own solution for mobile to make it work, to provide a good sense of quality, okay? So, unfortunately, this is the way it is right now. If you're looking at open source stuff, most of them are built, not for mobile first experience. That's what it is, right? And most of these standards takes a long time to rectify. Okay, they take a long time to rectify. Okay, so. And then there's always the discussion of client or clientless. Do you have a client or like a client, an app, or do you just have a web browser-based technology, right? Ultimately, ideally, you want to be able to do both. You want to be able to design based on both. But today, in this day and age, it is an app world. The world is built on applications. Windows 10 is going to be moving to apps. iOS is on apps. Android is on apps. So our philosophy is that you build an app first. The user will download your app if it's a good app. They don't care if it's a browser or an app. As long as you can build a good app, they will download it, right? I was a little boy here. The only thing he knows is apps. I don't think he knows what a browser is anymore, okay? So, I love to use the terminology because kind of like the way when I said, if you ask your kid, they don't know what radio is, Radio Shack is gone. It is exactly what it is, right? If you ask your kid, what do they use? And they say apps, and you know that, well, this is where it's going, okay? When they say they're using Snapchat, you know that company is going to be valued lots of dollars. If they're using Tinder, you know Tinder is the next big thing, right? I mean, there are some trends to that, right? It's not always right, but there's some trends to that, right? And then the last two things are quite key. In terms of supportability and deployability, how do you support it and how do you deploy it in terms of mobile? That's really hard. You've got millions of users right now running our app. How do you support and deploy? That's really hard. So you got to think about how to do that when you do mobile, okay? Hardware. We have some requirements when it comes to hardware. We got to be able to support 200 high-definition videos at a time. How do you do that? Today, no one can do it from the cloud. Okay, so we were the first to come out with it and from the cloud. But it relies on hardware to be able to do it. So you've got to be able to sort of specify the right hardware to do it, the right OS as well to be able to do that. The good news is today, my iPhone is more powerful than the PC I have at home. That's the beauty. That mobile thing that you have, screen that you have on the Tesla is more powerful very soon than the mobile that you have on your phone. Okay? So the good news is that the hardware technologies are continuing to grow. But we still got to be able to do other things like dynamic voice detection, echo cancellation, dual stream, dual screen recording, variety of things. It's quite processor intensive, right? Asynchronous communications are easy. You send a message, you just wait. Real-time communications require you to do dual stream, synchronization. You can't be talking and your video is delayed, or your video is here and you're not synced. So it's got to be, there's some processing cycle. So what we do is that we look at environments out there and optimize for that. We build two things. First of all, we look at products out there that we think will meet the requirements. Roughly, you've got to be able to at least get an i5 to work. Okay, i3 is possible, a little bit degraded, but at least an i5 level and above should be able to support that. And an iPhone, obviously, a minimum of an iPhone 4 or 5 should be able to do that, and Android as well. So you've got to be able to get some level of minimum on there. And then power, you've got to be able to design around power. The problem with using real-time communication is that they eat up power. So how do you design to minimize it when you're not speaking, you're just viewing, versus when you're sharing, versus you're not? You have to control the power and the performance, okay? And then obviously there's codec. The built-in video codec on some hardware engines out there. Your GPU has graphics processing engines, have got codecs in there that you can use, versus the software. When do you balance between the two? So there's a tightrope. When you use the hardware codecs or the camera codec versus the software codec, right? The truth is, if you're smart enough, you combine both, right? If you are just a recipient, you want to be able to just use the software. It's quick, it's dirty, and it's fast. You don't want to use a cycle. But if you're presenting, where you're generating and moving a lot, where you're on the generating side, you want to be able to leverage some hardware in there to give you the momentum to use this power cycle on there, because there's a lot of movement going on, and do that. So you've got to be able to be smart enough to detect when you use hardware and software, or a combination of both, to do that, okay? And then price point, make sure that, to go massively scale, that you can hit lower price point. There's a lot of discussion around Chromebooks and HP streams. These are $200 books. Can those do a high definition video conferencing, right? How do you do that? How do you bring it down to that level, okay? And then aesthetics helps. I mean, I hate to say that, but Apple has done such a great job with aesthetics. A lot of companies have moved to Macs now and Mac Mini now just because of aesthetics. So aesthetics with hardware is really important. Here's an example of what we have done with room system. Traditionally, room system, when you go in, you buy expensive stuff from Polycom or Cisco. They cost anywhere from thousands to hundreds and thousands of dollars. What we have done is that we have, software defined it. So you can just go out to Costco and buy giant ass TVs for less than $500 each. And then you can buy a Mac Mini for less than $500 now, an iPad for a few $100s, and then you have a good Logitech camera on that, and you can build your conference rooms for less than $2,000 for 2 to 3 screens, and you're done. Okay, so this is how you change the price point from tens and hundreds of $1,000s to sub $1,000 using off-the-shelf hardware and software and the cloud. It's all managed through the cloud, it's all deployed to the cloud, and it's easy. Okay? That's the way you change that around. Okay? Last thing is around API. As we talked about API, the key thing is around, when you build your infrastructures, you've got to be able to have APIs. What are APIs used for? For example, for us, right? We have APIs so that people can actually write on us. So we have companies out there that are doing, in China, for example, they're doing tutoring classes for English. Right? They're doing, they've got instructors in US and they've got students in China doing tutoring classes. So what do? They essentially have their own website and they have a business that they run. And then they use our API. When the student wants to meet with the instructor, they just click one click on the web, and the click then will enable the meeting to meet. This is all done via API, and then it will call our cloud. Okay? Same thing with healthcare. If you've got a healthcare business, you want to be able to get your doctor and your client to be able to meet on your website. So we create API so you can just activate that on your website as well. Okay? So it's all done by API. With mobile SDK, if you have a mobile app, you can incorporate our technology inside it, and then just by one click, you can then launch your application. You launch our applications inside your app as well, so mobile SDK. So you have to build that around as well. Then you have to do other sort of APIs like OAuth. We integrate with Google, we integrate with Facebook, we integrate with Microsoft, with AD. So you're going to be able to do a variety of other sort of integration as well in terms of APIs. Okay. And then API also allows other things like webinars. Some people use it for webinars, and then they can use the API to register on Marketo, they can register on Salesforce, and then use our platform as well. So these are webinars. Okay. So as of now, the technology really works because of two things. One is that it is cloud-based, that's one, and second, the price point is dramatically reduced. Essentially, you can now hold group multi-participants video conferencing at a fraction of the cost, much easier to use, cross-platform, has API, and is scalable. Okay? So as of now, we have around 65,000 businesses and education that uses worldwide. Here's some examples of schools that use it quite a bit in education. Texas A&M, they have an event where they actually talked about space shuttles and stuff, and this is all conducted using Zoom across that with their students. So they've got like mentoring students for middle schools. You have companies like this that uses us on their website. This is via API. They can use us and launch that on this side here. And then you've got teachers getting together with students remotely as well. They have lots of lower-end communities. Now they can actually get to go to school by being at home, right? That's really helps as well, okay? And then you've got lots of students collaborate on that as well. So education is a big market for us, largely because it helps. The cost of education continues to rise, not just in the US, but around the world. We do not have enough educators because it's not the most prestigious job, it's not well paid, but it is a good thing to do. So to be able to scale it, you've got to be able to use technologies to scale that, right? So that's one thing that we see is quite big. The next thing is healthcare. Healthcare is another area. So healthcare costs in the US is outrageous beyond that, right? But in countries like China and India, it will continue to grow because of the massive population out there. So how do you then ensure that the technologies can help with that? So we play a big part in healthcare as well. With that in mind, I just want to summarize. When it comes to software-defined communications, few things you have to remember. Design anything that is cloud-based on massive scalability. Think about massive. Once you design it, it's got to be massive. You've got to be able to scale. Second, always come in mind mobile first. When you're designing anything cloud, it's mobile first design. Third, leverage off the shelf as much as you can. Okay, that's how you're going to keep your costs down. High cost and cloud does not work. It has to be low cost and cloud, right? That's how it works. Okay, and then build an infrastructure of APIs for ecosystems to let applications built on top of that. Okay? That's it. Thank you.